start from the very beginning? None?
Yes, yes. You can start. Yes.
Okay, let's start. So I think we were here, or at the very beginning, I said I have always been the astronomer. I am originally from Germany, as you can hear from my accent. Normally I'm caught after the second sentence, and I got interested in the subject of astronomy when I was about 11 years old. I started to observe the night sky with my own telescope. This is a picture that shows me with my amateur telescope, and I started to use it in beginning of 1980, and I still use it today. Okay. After I got my German matric, I studied physics and astronomy at the University of MonSter, and in 1994 I got my PhD in astronomy. And these two pictures show me at the graduation ceremony. You can see me here wearing my PhD hat, holding the preliminary PhD certificate, and next to me my mother. Anyone who has got a PhD knows it is hard work to get there, and it's a major achievement once you have your PhD. On the right image here, we see me together with my PhD supervisor, Professor Waltraud Seiter, who was the first female professor in astronomy in Germany. My main duties after 1994 and 1996, I moved to South Africa, started working at UNISA as an academic, and my main duties were teaching and research. And for my research projects, I regularly went to international astronomical conferences to present my results. And this is a picture of all of us at the Galaxy Conference in Kiel in Germany in July 2002. The topic was the evolution of galaxies from simple approaches to self-consistent models. And the picture shows all of us, and I am standing here in between all the others. And I also went to the observatory at Sutherland regularly to do observations for my research projects. This is a picture of the plateau where the telescopes are. You can see the domes of 4 of the telescopes, of the 4 oldest telescopes, actually. Here we have the 1.9 meter telescope, the 50 centimeter telescope, the 75 centimeter telescope, and the 1 meter telescope in this dome. And the 1 meter telescope was the telescope that I used most of the time when I was at Sutherland. You can see some stars up here. And this is me at the telescope. The size that I was talking about refers to the diameter of the main mirror. What we see here is the telescope, the bottom part here. The telescope is pointing upwards, and the 1 meter mirror is somewhere in here. And then down here at the bottom, we can see the instruments. And you can see me standing there here, so you get an idea about the size of the whole thing. And being at Sutherland was always very special for me. It is a very special atmosphere. You sit at the telescope or actually at the computer all night gathering data. And then you have to regularly check the weather. So you have to get outside from time to time and see what's going on outside and see whether you have suddenly clouds or something. And then just standing there under this magnificent night sky, it was always very special for me being there and getting data, even though it was hard work. You work all night and you have 7 nights and you work from sunset until morning twilight. So they are long nights, but it was always very special for me being there and doing that. Then I have a hobby, which has absolutely nothing to do with astronomy. I play trumpet. There is a tradition at the German Lutheran congregations in Germany that they have brass bands, or I should rather say brass choirs. It is like a portable organ. It's like an orchestra with only brass instruments, so trumpets, horns, trombones, tubas, and so on. And they play in a number of church occasions, like services, but also other things. And in 1974, when I was 10, I started to play trumpet in Germany and joined the local brass choir. And when I moved to South Africa in 1996, I discovered that the German Lutheran congregations here also have brass choirs, and I joined the one in Pretoria East at the Johannesgemeinde, the German Lutheran congregation in Pretoria East. So this is where I was. I was here at UNISA doing astronomy, following my passion as a profession and also still as a hobby, playing trumpet in the brass band. Everything was great until we are now in the year 2005. In July, the 20th of July was the day when my MS career started officially. I had a relapse. I was diagnosed by a neurologist, and then I spent 5 days in hospital on cortisone. Then I recovered, and since October 2005, I am on disease-modifying treatment. But things got more difficult in the second half of 2008, or even a bit earlier, and then at the beginning of 2009, I lost my career as a professional astronomer because of my MS. I just could not work any longer. It was totally impossible. And since then, I am on disability pension at UNISA. So I am one of the lucky ones. I know that there are MS patients, when they lose their professional careers, they're falling into a financial catastrophe. Luckily, this didn't happen to me, but it was bitter. I mean, I didn't get a PhD for that. Okay, so now let's jump into to 2023. Now we are 18 years after diagnosis, 14 years after losing my professional career. Where am I now? I still play trumpet. I'm still the trumpet player in our brass choir. This has not changed. This is something that I am determined that my MS will not take away from me as long as possible. This is a picture of all of us playing in our service on the 2nd of October last year. So you can see me sitting here playing trumpet. We were actually 3 trumpet players. We were quite a small group on that occasion. The other 2 sitting here, and here we have the tenors and basses, and on the left our conductor. And then in 2014, I qualified for the Golden Pin for 40 years of brass choir duties. Our South African Lutheran Brass Band Association, they have a very nice tradition. Everybody who plays in a brass choir, and it doesn't matter whether it's all the time in South Africa or you also spend some time in Germany, that doesn't matter. If you play in a brass choir for 40 years, then you get a pin as a recognition of appreciation that you have done this for so long. And I started playing in 1974. So in 2014, I reached the 40-year mark. And this is a picture of all of us at the receiving the Golden Pin in 2014 at the Brass Band Festival in Durban. And we can see me standing here getting the pin, and I got it. This guy is Siegfried Prigge, who was at the time the chairman of the Brass Band Association. Yeah, next year in 2024, I will reach the 50-year mark of brass choir duties, and this is actually really something to look forward to. And I must say the Golden Pin is a bit of a symbol for me, something visible that shows that my MS has not managed to take that away from me. Okay, let's go back to astronomy. I still do astronomy as a hobby. I have lost my professional career. I also have lost Sutherland and the spectacular Sutherland sky, but I have not lost the stars. If I say I have lost Sutherland, in order to go to Sutherland, to the observatory and do observations, you need a research project. And then you apply at the headquarters in Cape Town for observing time at one of the telescopes. And if you get the observing time, then you go to the observatory for your observations. All of that is now for me a thing of the past. But I have not lost the stars, and I will now show you what I mean by that. My favorite object in the sky for many years has been planet Saturn because of its magnificent ring system. What we have here is a picture of Saturn taken by the Hubble Space Telescope, and we can see here the planet body with some cloud structures. We can see the magnificent ring system around here. The rings are not a solid body. They are made up of ice blocks. So we can think of something like a huge collection of ice cubes. It's frozen water. And they have the shape of a ring system. And what we see here is all our ice blocks. And then we see here this black line here. This is called the Cassini division. It's actually an empty region where we hardly have any ring material, so we can look through the rings in this area. And then we can see a shadow here. The sun is shining a little bit from the right, so we have the shadow of the planet cast on the rings here. And we can also see a little bit, I know it's very small, here, the upper edge of the shadow of the rings cast on the planet. And I've been observing Saturn with my telescope since 1980. And this is what I get. The first observation here, it's a collection of my observations since November 1980, the top one here. And the last one down here is an observation in November 2022. Now one can ask, why is Saturn so interesting to follow over such a long time? You could think of something like, well, if you have seen it once, you have seen it. But what you can see if you look at Saturn over the years, I've put down the year down here from 1980 until 2022, that the appearance of the rings changes. Here the rings appear very narrow, then they seem to open. Then we look at the rings at quite a steep angle, and then they seem to close again. Here we see the rings edge on, then they open again, but we're looking onto the rings from the other side. Here we're looking from the top, here we are looking from the bottom in 2002, 2003, and then they close again. What we see here are the seasonal changes on Saturn. On the Earth, we have seasons, summer and winter, and so on, because at different times of the year, the different hemispheres of the Earth are tilted towards the sun. When we have June, the northern hemisphere is tilted towards the sun, so the people in the northern hemisphere have summer. For them, the sun is high in the sky, the energy on the ground is concentrated, and the temperatures are high, it's hot. At the same time, for us here in the southern hemisphere, the sun is not so high in the sky, so the energy is spread out much more on the ground and the temperatures are low. In December, it's the other way around. Then the southern hemisphere is tilted towards the sun. For us, the sun is high in the sky and the energy is concentrated on the ground and it's hot. While for the northern hemisphere people, the sun is low and the energy is spread out and they have winter. And then we have March and September equinox. During those times, the sun is directly above the equator. This is why we have seasons. On Saturn, the situation is exactly the same. Saturn also has seasons. The only difference is that we have the rings that we don't have on Earth, and the ring plane is identical with the equator plane. So that means when we have summer on Saturn, if we have June on Saturn, then the northern hemisphere is tilted towards the sun. Northern hemisphere on Saturn has summer, and the rings appear wide open, and we look at a steep angle onto the northern side of the rings. This is what we have here in 1987. Then, when Saturn has the season of December, the southern hemisphere is tilted towards the sun, and the rings appear wide open again, but we look onto the southern side. This is what we had here in 2002, 2003. And then the equinoxes, when the sun is shining directly onto the equator, and we also look onto the equator. I should add here the direction of illumination on Saturn and our direction of view are very similar, because as seen from Saturn, the Earth is very close to the sun. At the equinoxes we have here, then we look edge on onto the ring plane. This was in 2008, 2009. We had it in 1995. Sorry, one moment. And we also had it in 1980 before I started my observations here. So what we are seeing is the apparent opening and closing of the rings due to the seasonal changes on Saturn. By the way, Christmas on Saturn was somewhere in 2003. And at the moment, the season on Saturn corresponds to our season at the end of August. Now I've put in a line here, this line. This line shows the time of diagnosis. So everything up here shows what I've seen before. This shows what I've seen after diagnosis. And now we can compare. I'm able with my telescope to see the planet itself, the planet body. I can see the rings. I can see a little bit of shadows somewhere here, for example. I can also see when the rings are wide open, I can see the Cassini division. So I can see all the large structures that the Hubble Space Telescope shows. And what do we see here? Actually the same. I can also see the planet, I can see the rings, I can see shadows, I can see cloud structures, I can see the Cassini division. So what have I lost? Actually nothing. The only thing that has changed over the years is the way how I record my observations. Until 2008, I did everything visually, and I made a sketch. I just had a piece of paper and a pencil, and I made a sketch. From 2009 onwards, I used my computer to make the sketches. And in 2017, instead of doing visual observations, I started to use a small webcam. But I have not lost anything, and I'm determined to carry on as long as possible. So again, I'm determined not to let my MS take that away from me. And I will carry on at least until 2025, when the rings turn edge on again. Now, next point, getting back to Sutherland stars. As I said, I have lost the Sutherland sky. Of course, theoretically, I could go back to Sutherland and as some kind of visitor and still enjoy the spectacular night sky. But I must admit, I don't want to. Because if I'm back at the observatory, I will just have it thrown into my face what I have lost. So I actually don't want to go back to Sutherland. So how can I get back to Sutherland stars? Yeah, of course, I can go to a different dark side. There are many dark, spectacular sites when it comes to stargazing in South Africa or generally Southern Africa. I can go somewhere else. And I've got friends in Namibia who have a farm, and I've been there a couple of times and will go there again soon. And they have also this spectacular night sky. But most of the time I am in light polluted Pretoria, where only the brightest stars are visible. And what I'm talking about now just does not just apply to Pretoria, but also to Johannesburg, Cape Town, Durban, to any other place where we have light pollution. So, getting back to Sutherland stars in Pretoria. The first point I've put down here is very important, something that we are often not aware of. The stars in Pretoria, and as I said, in Johannesburg, Cape Town, and so on, they are as bright as they are at Sutherland when we have a clear night, of course. We only put the light pollution on top. So the reason why we cannot see the stars in our light polluted cities is not that the stars have disappeared. They are still there, but the background is so bright. And for our human eyes, the stars seem to drown in the bright sky and we can't see them anymore. But the signal is unchanged. That means a camera can still see the starlight. So the solution is, if I want to get back the Sutherland stars at my home, is forget about looking up. You can't see them, but take pictures because the camera can see them. And this takes us right into the topic of astrophotography. And astrophotography means taking pictures of the stars and of the night sky. So now I'm sitting with the problem, with the question, can I do astrophotography from my home in Pretoria with my MS fatigue? Because like so many other MS patients, I'm suffering from fatigue, especially in the evenings, I'm very tired. How can I do astrophotography with MS fatigue? Of course, I have to do astrophotography the easiest way possible. The standard procedure of astrophotography is you have your telescope, you have your camera, you attach your camera to the telescope, but then you are sitting with a problem. We are living on a rotating Earth, and that means we experience a rotating night sky. So if I have my telescope pointed to some position in the sky and have my camera attached to it and take a picture, then I get images that are blurred in east-west directions. In order to get sharp images, I need a tracking device. That means I need a device, a motor on the mount of the telescope, which enables the telescope to accurately follow the sky rotation. And things like that exist, and this is what people normally do. They have a telescope, they track the night sky, and then they take their pictures. But setting up and aligning a telescope for proper tracking takes time and effort. And if I have to align a telescope before I start, I will be exhausted before I can start taking images. So all my limited energy will be gone before I can really do something. So what can I do now? Yeah, the solution is, if it's too much for me, forget about tracking. Don't use a telescope. Don't use a tracking device. Don't do any alignment. Don't use energy for all of that if you don't have any more energy left. So the easiest way is to take the camera, put it on a tripod, and just get outside and start taking pictures. But then I am also sitting with the sky rotation problem. And I don't track. But now the telescopes have very large focal lengths in order to get a big picture. If I have a moderate telephoto lens or even a wide angle lens or something like that, then the focal lengths on the camera lens are much shorter. So I'm able to take exposures or use exposures that are longer than I would be able to use with a telescope before everything gets blurred. So if I use a lens with a moderate focal length, then I'm able to expose, let's say, for a few seconds. With the telescope, you could only expose for a fraction of a second, one at most, so you would be very limited. And that means if you don't track with a telescope, you can take pictures of the moon or any other bright objects. I do my Saturn observations also without tracking. But if you want to go for faint objects, then it doesn't work. But in my case, if I have just my camera on a tripod and a relatively short focal length, I can use my short exposures limited by the sky rotation. And if I then take hundreds of short exposures, then I get a total exposure time that I can really get a good signal. What happens is if I have an individual exposure, then I have quite a noisy image. But if I take hundreds of exposures of the same field and combine them, then the noise goes down. And then the image, then the objects become visible. And this is how I do it. Of course, it means I have to do a lot of image processing later on, but that I can do during the day whenever I feel like it. But in the evening, it is the easiest way to do it. Actually, this kind of idea, anyone who has got a DSLR or something equivalent and a tripod can do from any place. Of course, you don't start with hundreds of exposures. You start with very small numbers. So a starting point for those who want to try it would be something like 5 or 10 pictures at the beginning, and then to learn how to do it, to do the stacking, get the necessary software, and start with objects that are so bright that you can easily see them with the naked eye, that you can find them. But this is actually the procedure that I do. Okay, so I have all my many images. Now I'm sitting with our light polluted night sky. The image I have here shows the constellation of Orion rising. I took this picture. It's a combination of 10 images, actually. Sorry? Somebody saying something? Okay. This is an image of Orion, rising Orion, taken from my home in Pretoria, and we can see how horrible the night sky looks like. We have some orange background here caused by orange street lights, and at the time we also had an orange light in the center of our, or in the middle of our complex. And this green contribution is here with compliments from the local shopping center. And this image was taken in 2010. So now with all the LED lights, the situation is even worse. So in order to get a good image, one has to get rid of this horrible sky background. And it was actually that image. I was sitting again at my computer in November 2010. I was desperate, really desperate. And I again said, I have to find a way to get rid of this horrible sky. And then I was looking again. And then for those who want to try it, in Photoshop, there is a function called median in the category noise. And if you use that with the largest radius, you are able to create an image which shows the night sky without the stars. And if you have that image, then you can remove the night sky contribution and only get the stars, and this is what I get. So if you see that, the sky has neutral color, this horrible light pollution contribution has disappeared, and the stars are visible. And as I said, anyone with the DSLR on a tripod can do something like that from any place. So let's now see what I can get. This shows the stars at Sutherland. This is a long exposure I did in 2008, still with a slide film. And this shows the problem of the sky rotation. I mean, it looks pretty, but still you see all the star trails here. And this is, of course, not a sharp image, but it shows how beautiful the night sky is at Sutherland. Now I would like to draw your attention to two clouds here. This one here and the other one here. They are two satellite galaxies of our own Milky Way galaxy called the Magellanic Clouds, the small one at the bottom and the large one at the top. The large Magellanic Cloud has a distance of 170,000 light years from us, the small Magellanic Clouds from 200,000 light years. And this is what you see at Sutherland. If you are at a dark side, you can see both of them clearly with the naked eye. This is what I get with my DSLR on a tripod, doing it the way I described in Namibia when I visited my friends in 2014. So here we can see the Magellanic Clouds again, now without star trails, so the stars are point sources. Here we have the small one, here we have the large one. And I think I combined 120 images or something like that. And also there you can see both of them beautifully with the naked eye. And here, if you have a look a little bit closer at the large Magellanic Cloud, we can see a bar structure here and some nebulosity around that. Now the question is, what do I get in Pretoria? The answer is that. This is the large Magellanic Cloud in Pretoria. And you can see all the structures that I was able to record in Namibia and that I was able to see in Namibia and at Sutherland. You can see the bar structure in the middle and some nebulosity around it. With the naked eye, the Magellanic Clouds at my place are now, and in any other urban area in Pretoria, the clouds are gone. They're totally invisible because of light pollution. And I think you have the same situation in any other big country in South Africa. With binoculars, I'm able to see the brightest regions of the LMC, this region here, the bar structure, and this bright cloud here. But that's it. Everything else is gone, but the camera can record all of that. So what have I lost? Nothing. Absolutely nothing. Okay, then I have two other examples of what I was able to record, both of them in Pretoria with all our light pollution. This is the Orion Nebula. It is a big cloud consisting of gas and dust. This is what we call a stellar nursery, because in this type of clouds, new stars form. What you can see here is a little bit of reddish emission. This is the hydrogen glowing, the hydrogen gas glowing. Then we can see something gray here, some gray emission. This is starlight reflected by dust clouds in this nebula. These nebulae have dust. This is dust in space is something like extremely small carbon particles. It's like smoke. And then we can see here something dark, like a silhouette. What we have here is the dust in front blocks the starlight from behind. And then we have the Sculptor Galaxy. This is a galaxy 11 million light years away. And we can see here some structure, but we look at the disk at a very shallow angle, and then we can see a little bit of structure here and also in the central regions. What I should mention here is that this image I took with the 85 millimeter lens. So for those who want to try it, of course it's cropped, 85 millimeter lens, 600 images, and had an exposure time of, I think, 2.5 seconds for the individual images. The large Magellanic Cloud is also, the image was taken with 85 millimeter lens, and for the Orion Nebula, I used a focal length of 154 millimeters. So that takes us to the end with the question, what has my MS taken away from me? Yes, my professional career, yes. Passion for the stars, no. Absolutely not. The stars themselves, no. And playing trumpet also, no. And I'm determined to not let this happen. And if we think something I should have maybe mentioned earlier, all these pictures of the galaxies and Orion Nebula and all of that, all this kind of taking pictures, I started in 2010 with my first digital camera. And this has evolved over the years into a huge project. So I have taken pictures of everything and anything that you can record in the night sky. So it is actually anything that I can get in front of my lens. And I was able to record things that I never thought earlier that I would be able to record. And then this all of this takes me to the conclusions. If I have to summarize living with MS in one sentence, part one, sorry for my choice of words. Part one, MS is a shit disease. But point two, one can still have a good and fulfilling life with it. And point three, both parts of the sentence are important. I have a bit of a problem if I get messages, read people saying something like, just think positive and everything will be fine. It doesn't work like that. At least negative experience is 24/7. So it is not just everything is great, but also not everything is bad. What I experience is the whole range from easy to difficult. And what I try to do is to have a life where the positive aspects have a greater weight or are more or bigger or whatever than the negative aspects. So it is something like the sum must be greater than 0. Then I will be fine. And that's it. So I can only thank you for being here and listening.
you. Thank you, Barbara.
Thank you,
Thank
Non.
you. Thank you for sharing your wonderful story of dreams and overcoming those limitations.
Thank you, Non. Yes.
We're looking forward to your 50-year next year. That would be
Yes.
wonderful to share it with you. I think we can now open the floor for everybody if they have any questions. If you want to stop sharing your screen, then you can be on the screen.
Okay, let me stop sharing it. Yes.
Okay. And then I will allow everybody. Everybody can now open their own cameras and unmute themselves. And then maybe if they have any questions, you're welcome, guys, to ask your questions or have any comments to make. Please unmute yourselves. There you go, Karsten.
Hi.
Hello.
Hello.
Maybe just a comment in terms of light pollution. I mean, we're starting, you remember, we start playing around with modeling light pollution in South Africa way back in 2004 or something. And at that stage, actually, nobody really in the landscape development and that sort of stuff, nobody really knew what it was. And you will be glad to know that these days it is actually a design criteria. People are aware of it, and they take recognition of it when they design development. So yeah.
Yeah, that's really good news if people start to be aware of that, because I have seen over the years, if I compare my images of 2010 with the images I took recently, that the light pollution.
We lost you there for a minute.
I'm still here.
You
Oh,
froze
sorry,
for a minute. We
repeat?
lost your voice.
Oh, sorry. I just said I'm glad to hear what Carsten said, because I see in my images how the light pollution has become worse since 2010.
Interesting.
Yeah.
Yeah, that's yeah. So, So it's important to keep all the images I took some years ago, because the sky was not as bad as it is now.
Mm-hmm.
Yeah,
I see
this blue LED lights are horrible for light pollution.
Mm-hmm. I see in the chat box, Christina said, vielen Dank. Pia Male says, herzlichen Dank, dass ich teilnehmen durfte. Sehr gut gemacht.
Danke, Pia.
You're welcome to unmute yourself, guys, and have a conversation with Professor Barbara. Any other questions?
Hi, hello, Heike here. I don't have a question. I just want to say that I find it admirable how you deal with your MS, and that you take it so positively, to see that it hasn't taken anything away from you in part of photographing your stars and that. And I just admired the way you deal with it.
Yeah, thank you, Heike. I mean, we know each other for so long, so we have seen some of that. Yes.
Yeah.
Yeah, I know from our common holidays, I'm the one when we go somewhere getting
Yes.
outside with my camera at night and complaining about lights and trees and everything. Yes.
Yes, but it's sometimes, if one has an illness, and that easy to see the negative side and just give up.
Yes.
And
Yes.
it's such an not an honor, but so nice to see that you have not given up, and you're fighting it and taking the best out of it that you can, and that is so nice to see.
Thank you.
Yeah, you're welcome.
Thank you. I must admit, it's many, many years ago, Barbara. I don't know if you can recall when we first met, maybe via email. But
It must have been in 2014 in connection when I got the golden pin. This was the first time. This was in 2014.
Okay, was that when I did that article on you in Rolling Inspiration?
Yes. Exactly. This was that article. Yeah.
Yeah. We still have that, and it's showcased, but it's a really long time, and it's nice knowing you and seeing that you're forever optimistic and positive. It's really great. I admire you for that.
Thank you. Thank you.
In spite of having this good appearance, multiple sclerosis is not easy to live with. And many people with MS have a different experience. And for those people, we are always thinking and hoping that there will be a change.
Yes, I mean, there is a reason why when I put in the conclusion the first part of the sentence. I mean, like everybody else, I am dealing also with symptoms, and one has to live with that. But I also know in some ways I seem to be one of the lucky ones. There are many people who are worse off than I am, but it's not something like there is nothing. I mean, the reason why I can't work shows it.
Yes, that's true.
So, yeah. And like with so many people, I'm one of the people where you can't see it. People always say, but you look so well, and we can't see it. So what I'm for the first time going to do next week at the next meeting of the senior association in our church. I'm also giving talks regularly. They have monthly meetings, and they always need speakers. And I used to talk about different astronomical topics over the years, but coming Wednesday at the next meeting, I will give them an MS awareness talk with my story, but also with MS awareness.
Yes.
So because it happens so often that they don't, they're totally surprised if I tell them something. It happens regularly because it's not visible.
Yes. Odette Farrow is making a comment. She says, thank you so much, Barbara. Your passion and mindset is an inspiration. Thank you and thank you to me. Thank you. Thank you, Odette.
Thank you.
Dottie is asking, are there more satellites than in 1970 today?
Yes. Yes. The number of satellites has increased dramatically. We can, especially after people like Elon Musk are sending up these mega constellations, these big numbers of satellites. It's a nice idea to have internet everywhere, but these satellites are flying in quite low Earth orbit. So when the sun is shining onto them and we have darkness on the grounds, we are able to see them, and even with the naked eye. And this is a big problem for astronomy. It is forecasted that in, I don't know when, maybe in a few decades or something, we will have the situation that even in a dark site, the night sky will be flooded with satellites, and there might be more satellites and stars that you can see with the naked eye. I hope I will not be alive anymore when that happens. So
Oh,
it is a problem. So we are sitting not only with light pollution because of the light from the ground, but also the satellites are a problem because they are so bright. And then if they're flying through your field of view, then you can throw away your images. And that will become, it's an increasing problem for astronomy from the ground. Yes.
Interesting. I think we normal people, often when we look at the stars, we're not sure whether we're seeing the night star, the evening star, or whether we're seeing a satellite. We don't know.
A satellite is an object that moves. It has a bit an appearance of a plane, but it's not blinking and there is no noise. If you see the ISS, for example, the International Space Station, it's like a bright star, but clearly moving across the night sky. So you can recognize a satellite.
Okay, thank you. Anina Stein is typing a message. Dottie, I hope that answered your question. Donovan is coming back into the meeting. Hi, Donovan.
Hi, Non. Hello.
Hello. Donovan, do you have a question?
No, Non, I don't have a question. Sorry, I was just busy. I got distracted with network issues here.
Oh, okay. All the way from Portugal. Donovan is tuning in all the way from Portugal.
Well, Heike is from Finland, Carsten is in Sweden, people from Germany.
That's great. And then here in South Africa, we're all over the show.
So it's a worldwide meeting, which is very nice. Thank you.
Yes, very nice. Anina Stein is still typing a comment or a question. Anybody else would like to say something now that you have an opportunity?
This is Dottie Moss. Thank you very much, Prof. It answered my question. I remembered as a kid in Citrusdal, we used to look up and it was an honor to see a satellite. And nowadays I'm convinced I'm in Joburg and there's many, many, many satellites at night when I look up.
Okay, because I don't see that many. I think what one also has to make sure, you can easily confuse planes and satellites. That can happen.
Now, I know a satellite. I remember as a kid, and these are okay, I won't say many more, but as a kid, it was an honor to see one, maybe two at night. But nowadays, last night, my husband and myself sat outside, and within seconds or within minutes, I saw one, and he said to me, "Just look around at the back of you. There's another one." Maybe they're more visible, as you say. They're lower than they used to be. That it's more noticeable than it was those years.
Oh, I see. Okay. The point is that there are many more satellites than decades ago. The number just increases, and then of course you see them more often. That's true. Yes.
Yeah. No, I agree with that. But I want to ask something. I'm not very knowledgeable about this, but I do like to look at the stars. It just interests me.
Yes.
In the evenings when I look up towards, I'm not very, very convinced which way is east and west and north and south, but I think it's towards the west. There's a star that's very bright.
You mean in the early evening?
Yeah, round about say 7, because that's when I take the dogs out.
Yeah. Is it
There's a
high
star
in the sky or is it low in the sky?
low.
Low. Then you are seeing Venus low in the northwest, our evening star that we can see low in the northwest when it gets dark at the moment.
Okay, that must be it. Thank you very much, Prof.
Okay.
Thanks for your contribution. I enjoyed it very much.
Thank you.
Thanks for that question, Dotsie. I really enjoyed the answer. So now I'll also have a look. We are also asking ourselves that same question.
Okay.
And now,
yeah.
it's
So
the
if you have a
evening
look
star.
in the northwest, when it gets dark, Venus is very bright. It's quite low, but it's quite bright. And if you look into the northwest direction, then you will be able to see it. You cannot miss it.
Okay. I see that Nina said, thank you, Barbara, for the wonderful presentation on the stars and showing that even though we have limits, we can adjust and solve problems just from another point of view. That's Anina. And then Nicole said, I think Nicole's already in the UK. Thank you for being such an inspiration to others, Barbara. And WGJ Pretoria, I'm not sure who that is. Greetings from Eisenach. You are an excellent motivational speaker.
Oh, okay. Yeah. Yes. Danke, Walter. Yeah, I know. Yes.
Okay.
Yes.
Okay, lovely.
Mm.
Okay, that's a really, really nice comment that, and we appreciate your attendance here today, guys and girls. It was really nice seeing so many of you. I hope it was a wonderful experience for everyone. If there are any more questions or comments, you're welcome. I wish everybody would show their faces now.
Yeah.
Linda said she joined, she battled to join. There you go, some faces to see.
Heike.
So let me go and people and participants. Stop all spotlights, and now we can all see one another for a change. There you go.
Okay, you're
Hello,
also
Susan
visible,
and Joe. Hello. Hello, hello, everybody. Nice to see you. I'm going to upload this presentation soon, and then we can just share it with people who have missed it today.
Okay.
Okay. Hello, Nicole. Okay. So if you don't have anything more to say, to add, then Professor Barbara, you can have the last word.
Oh, I was not prepared for that. Okay, I can only say thank you very much for being here, being interested this morning. And yeah, I hope it was not too technical when it came to the astrophotography part, but this is one thing, this is that has nothing to do with my MS, but with astronomy for many years. We have, if you read all the news, there are so many great telescopes on the ground and also in space, and these big ones, and they achieve great data, and they're doing extraordinary things, which is absolutely remarkable. But this creates an impression on astronomy which is a little bit biased. It happens sometimes that people think, well, in order to do astronomy, I need a big telescope, I need a big observatory, otherwise I can't do anything. And this is not true. what I always found interesting, even much before I was diagnosed, is to do things with moderate equipment. The bigger the equipment is, I have the feeling the more is in between me and the stars. And the smaller the equipment, I feel closer. And it is, as I now see with my camera on a tripod pictures, it's amazing what I can do, what one can do without a telescope with moderate equipment, no matter where you are. So it's not like I'm in a city, I can't do anything. When I gave a technical talk on the astrophotography topic of the pictures that I do a month ago at the Astronomical Society Pretoria Center meeting, then my last sentence was something like, being in a light polluted site and only having a camera on a tripod is no excuse for not taking pictures. So it's amazing what you can do with very small equipment. And so that's also something to get people interested in the subject. No matter where you are, you can get outside, have a look up, take a camera, take binoculars, or even with the naked eye. It's amazing what you can see. You only have to start looking. And that's something that always fascinated me. And with the Saturn story, when I'm finished the first 30 years, because this is the whole season on Saturn, and then this was published in MNASA. This was in beginning of 2011. Then I also put that in. This is one of the motivations for me to use these, to do these things, and also to publish these things, that other people can get interested in the subject and start with wherever they are with whatever they have.
Interesting. Yes, absolutely agree. It's like we grew up, like Dottie said, we all grew up in South Africa lying on the lawns at night with our parents, being told what the stars mean and where the Milky Way is.
And nowadays, if you get outside, there is no Milky Way because the sky is so bright. Yes.
Yeah, so it was quite a special time during the first start of COVID, when everything was so dark and it started showing up so bright.
Yes, yeah.
Yes, you're welcome. Walter?
I think Barbara is the only person in the country that enjoys load shedding.
Yes, well, I'm not the only person, but I know we astronomers enjoy load shedding. That's true. Yes. Yes.
Yeah. Good observation. Yes. Yeah. How are things doing? Do you see the stars in the UK, Nicole?
Not at all. You don't really see them. You must really be looking. But I guess I'll definitely be looking from today onward, for sure.
Where are you in the UK?
I'm in the southeast in the UK. So in London.
Not in London.
Yeah, in London.
Oh, in London. Well, then I suppose it'll be difficult to see a star, especially with the weather.
Yeah.
Any tips for Nicole on how to see a star in London?
Well, it's the same like here. You get outside and have a look. The only difference is that the weather is worse, so you have less clear nights. But I think the light pollution in London is as bad as it is here.
Okay. Okay, that's interesting.
Yeah, if I mean, I'm talking about Pretoria, Johannesburg, this area. So any big city, it's a worldwide phenomenon that you have horrible light pollution.
Yes.
And if we, yeah.
And Barbara, do you want to say something about the Hermanus station, NASA station?
Oh, I'm not an expert on that, I must admit. I know that they're doing measurements of the magnetic field, but I'm not actually, this is a field that's different from what I have done. Because at Sutherland, I did observations of galaxies in the optical and near-infrared wavelength regions. So it's a totally different kind of measurements and totally different field of studies.
I see.
So sorry, I'm not an expert on that, so I should not try to say much about it because I'm the wrong person for this.
Yeah, we're very fortunate to have the station here.
Absolutely. I mean, one thing is very important. If you want to measure the magnetic field at different places on Earth, then you need the different stations. And the Hermanus one gives the data for this region, Southern Africa or South Africa.
Yeah. Yeah, we have open days here, and then we can walk through and they tell us all about it. In fact, one of our tenants in a little small flat we have down the road, she is an employee of NASA now. I'm not sure what she's doing. She's brand new. I'm going to speak to her and ask her and tell her about you.
Yeah, I mean, then she is the one who can answer the question about, yeah.
Yeah. Very interesting. Okay.
I must also say, I mean, I've been out of action for so long that I'm also not familiar with the new things in science anymore. You just lose track.
Yes, I'm sure. Yeah. Donovan also said, thank you very much for the journey and the inspiration. That's it. That's the end of the messages. Well, Barbara, thank you so very much. It was enlightening and I liked it, and I'm glad it got to work in the end. We'll work on the recording and see what we can come up with to smooth it out. Thank you, guys. Thank you so much for joining. It was really nice seeing all of your faces. And thank you, Professor Barbara, for making it a special morning for us.
Yeah, thank you, all of you. Thank you for being here. That was really nice.
Okay. Goodbye.
Thank you for the
Bye,
invite.
everybody.
Bye-bye. Have a nice day. Wherever you are. There you go. Then I will go to people, and so I can stop the recording only once everybody is left.
Okay.
There you go. I think it's only you and me.
Okay, only the two of us. Yeah.
Yeah. So let me stop that. Stop the recording.